This conference will now be recorded.
Hello everyone. Sorry for the delay. We are contacting the speakers via telephone. Since I hope everyone is here and we have a lot to cover, we really should begin today's webinar. I really appreciate you all for attending today's virtual conference. A very good morning, good afternoon, and good evening to one and all present here virtually with me today. Let me introduce myself. My name is Clara McBroom, Conference Secretariat at Coalesce Research Group LLC, and I will be available for any of your queries or questions throughout the webinar to help you out technically or organize the webinar successfully. I would like to thank you all the attendees and participants of today's virtual conference, and I hope you enjoy the webinar and gain knowledge from the sessions. We also hope your participation will contribute to new research findings and that will lead to new collaborations and research initiatives. Before we start with the sessions, I guess some of you will be new to GoToMeetings app. Let me just explain you the important tools required for the presentation. On the GoToMeetings app or a web page, you can find four icons of the bottom center: mic, camera, screen, and end button. Mic button. Click on that to mute or unmute yourself. I request you all to stay muted while our speakers are presenting their research work so that it doesn't cause any disturbance to them. Camera button. You can use this button to share or unshare the web camera. If you have the option to share the web camera, you can do it and it is completely your choice. Screen button. You can use this button to share your screen. This is main part. During your presentation, after I call your name from my side, I will be making you the presenter and will give the permission to share your screen. Then only you will able to share your screen. So once I make you the presenter, you can click on the screen button and you will find a pop-up window to share your screen. End button. This is the fourth icon where you can use it to leave the session. On the top center, you can use the option to change your display settings. At the top right corner, you will have three icons: people, chat, and settings. In the chat option, you can chat with me or any other participant. For the settings, you can use this button to check for the settings of your speakers or microphone. So as mentioned, so kindly mention So kindly remain muted during the presentation so that the presenter does not get disturbed. And for any questions, you can ask the questions or you can send your questions in the message box too. Well, let's not take much of your time. Finally, I would like to request you all, please give us a brief introduction about yourself before starting with the session so that we can know about you virtually. And now let's move into our session. The first presenter is Manojit D from Guru Ghasidas Vishwavidyalaya, India. Hello, doctor. Are you ready with your presentation?
Yes, I'm ready.
Now I'm making you as a presenter. Kindly
Yeah,
click on the share button to share your screen.
I think it is visible, na?
Yeah, your screen is visible now. You can continue with the presentation.
Okay, okay. First of all, thank you. Thank you for inviting me or give me opportunity to deliver a talk in this international webinar of the ceramic and composite material. And Dr. Manojit De. I'm Dr. Manojit De from Guru Ghasidas Vishwavidyalaya. It is in India, Central India. And right now, I'm working as an assistant professor in Choksey Group of College, and it is also in India. The title of the today's talk will be that studies on sodium niobate modified bismuth ferrite ceramic systems and finding the morphotropic phase boundary by using XRD Raman analysis, and structural and other dielectric and impedance conductivity analysis for this sample. Now, this slide contains that's layout for this presentation, today's presentation. This is the Bismuth ferrite, that basics and some experimental techniques and result, whatever I get, and discussion about that, and conclusion, then acknowledgments. Now, first of all, the multiferric is this bismuth ferrite material. Basically, this is a multiferric. Before going to the detail about the bismuth ferrite, we have to know about the multiferric. Multiferrite is a type of material in which there are different ferroic properties or primary ferroic properties that combine together in a same phase, and there are different primary ferroic properties. There is ferroelectricity, ferromagnetism, ferrotoricity. These are different example. If we find any two combination of any two in a same phase, then we can call it the multiferric. First, Landau and Leibniz postulated the theoretical existence of the multiferric about 1959, and after that, around the 70s, there is a very little bit interest about this type of materials. And after 2003, there is a paper came from Dr. Ramesh, Professor Ramesh lab from USA. After that, there is a lot of enthusiasm, lot of research is going on that artificial multiferrics and its property study, how it will use for the different purpose. And because of the fundamental, lots of fundamental physics are involved in this particular field particular field. That's why it is very much interested by the research community, as well as different type of application like spintronic and different sensor are there. That's why it is very much well accepted for the research communities. Now, in the case of multiferric material, how the multiferricity in this case, basically in the bismuth ferrite, it shows the antiferromagnetic. In the next slide, I will show that, and magnetism, antiferromagnetism, and ferroelectricity in both in a single phase. How? In this case, the magnetism is basically come from that localized electron in a D or F cell, as well as exchange interaction, that is the magnetic ordering that leads to the magnetic ordering. If we look this Venn diagram, in this yellow section, this is the purely ferroelectric nature is there, and this is the magnetic nature is there, and the common portion which is shown in this green section, this is the multiferric region. Okay, and coming to the ferroelectricity, how this ferroelectricity is generated in this type of material. It is the main source of this ferroelectricity. Different microscopic sources are there, and two types of depending of the coupling between the magnetism and the ferroelectricity. This is the basic structure of the bismuth ferrite. This is basically a perovskite structure. As we all know, that perovskite structure contains that AbO3 type of structure. These bismuth atoms are means share in the corner position, and oxygen is in the center position, and sorry, yeah, oxygen is the face center position, and Fe is in the center position. Okay. In this bismuth ferrite, it is basically the structure is rhombohedratically distorted perovskite structure. In one unit of bismuth ferrite, there are two formula units of AbO3 structure. This is one is shown here, another is shown here, are clubbed together, and these are connected with the one side of that direction of the sides. In the case of bismuth ferrite material, it is basically shown that G type of antiferromagnetism, and its Nil temperature is around 643 Kelvin. And how this D type antiferromagnetism is work, it is shown in this figure here. If we are looking, this is the electric field, this is magnetic field, and this is the resultant of that. It is continuously moving, and after we can say this is a wavelength. We can say from here this resultant is rotating with clockwise, and after the length around 640 or 620 angstrom, it is completely in the first position, like the first position. And if we are looking about that, there are there are Fe3, that is which is in the center atom, that surrounded with the nearest the Fe ions that have the spin down, and the center one is the spin up one. This is known as the antiferromagnetic type, and this type of cycloid type of known as the G type antiferromagnetism. In the case of ferroelectricity in this bismuth ferrite, it is basically come from the structural disorder as well as off-center shifting of the bismuth 3 plus ions as well as Fe3 plus ion. And ferroelectricity basically comes from the position of the lone pair in the bismuth ion. Here it is shown in this yellow picture. Now, coming as till now we know about the basic structure of the bismuth ferrite and how it is connected, and this thing, sorry, and now coming to the what are the problem actually basically that are associated with the pure bismuth ferrite. Because of the presence of the Fe3 ion and the volatility of the bismuth ion, that formation of the secondary phases in this particular type of material, as well as anion and cation vacancies are there. That vacancy basically help to carry the current also, and that's why the high leakage current is there and low dielectric constant is there, and the high loss tangent that limiting for the different device applications. How we can remedy and we can get rid of from this type of problem? Basically, one can substitute the materials. One can substitute the material substitute, that is A side as well as B side, and they can suitable material by substitutable material to fabricate the composite to enhance the ferroelectric as well as ferromagnetic properties also. And the synthesis by using the solid solution with the different other type of perovskite structure as well as other material. Here in this section we will discuss about the bismuth ferrite that mix with the make the solid solution with the sodium niobate, that is the room temperature antiferroelectric, and it is like that. And we will show the how the structure changes, how the properties, basically the electrical properties as well as the phonon mode properties, how the changes with this solid with the making the solid solution with this sodium niobate. Here in this slide shows the experimental flowchart of my work. And first it is this material is synthesized by the solid state, well-known solid state synthesis method. And first of all, the samples are taking and a weight percent as a stoichiometric amount, then grind it, then make it calcine with some suitable temperature, then again grind and mixing. And from here you can take one XRD there for take to check your material whether it is getting from the desired phase or not. And after that you can pelletize it and again sintering, basically in calcination the whatever the unwanted material like carbon dioxide, water that are blown away from that material surface, as well as in the sintering temperature, that is the phase formation, whatever the micro nucleus is there that are getting the club together and form the some phase. And when this is happening, then our material is get ready for the characterization, and we can take the different type of characterization, the XRD, vibrational spectra, semi-rex, and dielectric and electrical characterization. Here, in the case of XRD, here we have synthesized that sodium niobate modified bismuth ferrite, a series of material that is X is equal to 20, X is equal to 0.25, 0.30, 0.32, 0.38, and 0.40. Basically, the plan for synthesis of this type of series, because of when I start that work on this type of material on this series particularly, I saw some two or three reports are there regarding regarding to this type of ceramic samples. But what happened when I they just present the some structural changes are there, but they are not showing why these structural change are happening in this particular series of sample. Here one can see that when the sodium niobate concentration is 0.20, then and 0.25, 0.30, it is written as the phase, crystal phase is written as a rhomboidal structure. Okay, and when it is the 30.32 and when it is above that, then it is the cubic structure. Hence we can find a morphotropic phase boundary near x is equal to 3.31. If someone can try to debate also that how you can confirm it. Yeah, we have confirmed and we have checked it with this picture is more getting more clear if we take a very short range of the XRD spectra. Here we took the XRD spectrum, it's from 31 2 theta is equal to 31 to 33. Here it is clearly visible some rhomboidal, that is doubly splitted this spectra, X-ray spectra, that getting and merged together in a single peak. Okay, as well as around 37.5 to 41.5, we can find these two peaks are merged together in a single cubic, that's 111. As well as same thing is happening in the 54 to 60. There are also the three peaks are merged together in a single peak. This type of thing happening when there is a structural phase transition in this material, happening in this material. Now why this structural phase transition is happening? To calculate to find out the answer of this question, we just calculated the strain inside the material. As we know, when we just incorporate the foreign atoms or foreign molecules in a particular stable structure, then there must be some strain will generate inside the crystal structure. Okay, when the crystal structure uh, up to that level it is able to sustain that strain amount, it is okay, and when it is go some beyond of some energy, some value, then the structure may changes. This is happening here also. When we just doping with some lower concentration, the strain is continuously increasing, and after some value, the strain is suddenly that breaks the unit cell, that strain so much produced in that unit cell that it is break along the one axis. If we look into this stability picture, we will get more clear. Here strain after 0.30, it is suddenly enhance a lot of time. Okay, this is the main cause for the structural phase transition for this type of material. Here we just calculate the lattice parameter also. You can see here, one can see here that previously that rhomboidal structure is there, and after that it is came into the cubic structure. As well as the using Serrat formula, we has calculated the crystalline size and tolerance factor also we calculated here. Okay, now this is the same FESM images of the all compositions, and this is shown that some near to the spherical type of structure is there. In this grain size, clearly visible grain and grain boundaries are there. There are some small pores are there because of the high temperature sintering. I think this is because of the high temperature sintering happening in the for these samples. Now when we took the EDS spectra element for the elemental analysis, there is no such extra peak find out for that for this type of material. But if we calculate this weight percentage, it is well matched with the theoretical percentage as well as the experimental we have whatever we have collected from it. And this is one of my composition. I took the elemental mapping for that, that is x is equal to, this is for the x is equal to 0.20, that all the samples, that is oxygen, Fe, natrium and bismuth and sodium, all are well present as well as all are distributed over the surface, whatever the scanning surface we are looking for. Okay, and this data is published in the Journal of Material Science, Material and Electronics in 2017. Now coming to the Raman analysis, what happened in the Raman analysis, how we can find. Let us think like this. If one student is get entered in a room and room is completely blank or completely empty, then that student can travel at any direction from one corner to any other corner at any type of fashions. Let take a second situation is like this. If we get into another 20 or 20 student in that room, then what happened, these students are not mobile. Okay, the second student whatever they get entered in the room, that are not mobile, these students are not mobile, they take their position only. But what happened to the first student, whatever the frequency, whatever the direction was, that was in his or her, that get restricted. Okay, similarly here also, in the case of material science, here when the foreign atom doped or make a solid solution with the material, then the vibration, lattice vibration, that is known as the phonon mode vibration, that get restricted in a particular site. Here by the Raman analysis we can find this type of phonon mode and how it is getting changes with the doping concentration. Below the 250, there are three Raman active modes, that is known as A11, A12, A13 are there. These are shifted towards the higher angle. Why it is so, we will discuss. Again, if we see, if we watch in this data, as we increase the concentration of this sodium niobate, this peak get diminished. That's why, because of the stereochemical activity of the bismuth ion or lone pair, we can say that getting changed or that getting lower. Now coming to the question, answer for that question, that why this A1, A12 and A13, these are moving toward the higher angle. Because of the, it is very simple, we can find the frequency, and frequency is directly related to the inversely proportional to the reduced mass of this particular site. When we looking for that uh, navia sodium niobate, the sodium is going to the A side and it is replacing some bismuth atom. Then what happened? This sodium, the reduced mass of that particular site is getting lower. That's why the frequency is shifted to the higher frequency range. Okay, and the decrease of the Raman spectra near to the 430, that is E4, that is attributed to the B site of the cations and the octahedral tilting under the lattice strain, high lattice strain, and the volume of the unit cell that compress, and consequently leading to reduction of the octahedral tilting. Now coming these two, now these two can be correlated. How the origin of the structural phase transition, whatever we are looking for in that XRD pattern, and whatever we get in the Raman spectra. In the octahedral tilting, we can correlate the basis of it by using the tolerance factor formula. As it is well established that as the tolerance factor getting lower, there must be some octahedral rotation inside the crystal. Here that octahedral that formed by the Fe with the 6 oxygen around it, it started rotating as we increase. And when it is rotating, and in this present study, the continuous increase of octahedral rotation that makes rhombohedral structure less unstable, and cubic phases getting stable as we increase the doping concentration. that thing are directly depicted from the peak margin in the XRD pattern. Now coming to the FTR, it is also one of the vibrational structure that we can find. Here actually we took it from the 400 centimeter inverse to that is around 3500 centimeter inverse. Now whatever the higher frequency, this is related to the some functional group, we all know that. But being a material scientist or ceramic people, we have to check the lower frequency, and we have to check the how the vibrations changes with the lower frequency. Now here look this insert figure. This is one of the my FTR spectra of one of sample, that is x equal to 0.20. Now we took the 500 to 650. It is near to here only. Okay, when we try to deconvolute this spectra, we get there are three spectra that are merged together near 533. It is because of the octahedral, that is the rotation, that is the vibrations related to the bismuth and oxygen octahedra, and this is related to the FeO6 octahedra, and this one that is near to the 603. This is because of the out of phase vibrations of the oxygen atom, that's normal to the 111 plane direction, that's along that is connected together, and other rhomboidal structure. Okay, now coming to the dielectric, all this is this figure shows the frequency dependent dielectric spectra of all composition, and the insert figure that is that's shown the different loss tangent with respect to different temperature as well as frequency. And okay, yeah, in the case of frequency dependent dielectric, it is depicted that magnitude of the dielectric constant decreases with the frequency of measurement, and all samples tend to the same vibration, same fashion, try to follow the same fashion. In the case of temperature dependent, that is one thing is very much important to say, that is due to the thermal energy, this try to overcome the activation barrier of the polar molecule that orient to the together the direction of applied field. Now in this figure, the real part of the impedance analysis is plotted with respect to frequency. All the type of sample shows the same type of behavior, and here it is shows the temperature frequency as well as with different temperature. This is the imaginary part of that impedance shown here. In the case of a real part, that Z prime is reduces with the temperature and the frequency, suggesting the increases of the AC conductivity. At the high frequency region, due to the inertia, the space charge polarization unable to follow the frequency variation almost ceases. As a result, the real part of the after 100 kilohertz, it is get coincided with the single line. And around now coming to the imaginary part, this imaginary part that depicts actually basically that different relaxation species of the for different polarization mechanism. Now if we look for the impedance channel, that is known as the Nyquist plot. In the y-axis, imaginary part of impedance is there, in the real part of impedance in the x-axis. Here if we look in different temperature, and this is the fitted line here on the this sample, this is x is equal to 25.25, this, and the lower temperature it's form a single semicircle is there, and when it is about to high temperature around 250, more than 250, it tries to make two semicircle structure. One is then that depicts that depicts the grain boundary effect also. Now if we take the data structure of this, And for the case of x is equal to 2 0, there are three type of contribution are there for the grains from the grain boundary and the electrode effects. And electrode effect come in the higher temperature. From this grain resistance, we can find that it is continuously decreasing. Hence, this type is known as the negative temperature coefficient of resistance. This is NTCR type of behavior. And for this x is equal to 2,5, it is also shown that NTCR type of behavior. Here also some electrode effect is there, electrode resistance as well as electrode capacitance in the higher temperature. And for the x is equal to 3 0, it is also NTCR type of behavior showing here. But in the case of x is equal to 32.32, there are resistance due to grain that are decreasing and as well as some increasing, because here it is decreasing and then this is increasing and again decreasing. This is both type of PTCR, that is positive temperature coefficient of resistance is there, as well as NTCR behavior are there. In the case of x is equal to 3,5, there are both NTCR and PTCR behavior are there. X is equal to 40 also there. Now one can find that when we are in the below x is equal to 30, that is purely NTCR behavior is there. Again, this is purely NTCR behavior is there. Here also NTCR behavior. But after when we are going to the x is equal to 32, just after the monophotopic phase boundary, both the PTCR and NTCR behavior is there. And after that it is continuous for the PTCR or NTCR behavior. Okay. This the depressed semicircle that shows the some depicts the non-divide type of relaxation mechanism is there. And okay, now coming to the conductivity analysis. Now coming to the conductivity analysis, this figure shown that AC conductivity in the y-axis and the frequency with respect to this. Now, if we this formula we have followed here, this is the AC, sigma AC is equal to sigma DC plus A omega to the power n. N is the frequency exponent here, and this n suggests some theoretical values, theories are there, and n suggests how the conduction mechanism work in this particular sample. In the case of if the value of n is continuously decreasing, then this shows that the correlated barrier hopping type of conduction mechanism are followed by this material. And if n is continuously increasing, then some small polaron based conduction mechanism are there. If this is a combination of these two, primarily it is decreasing and then increasing, then it is the some overlapping large polaron conduction mechanism is there, that is known as the OLPT. Here for x is equal to 30, in this case it is decreasing then increasing again here. Okay, only this type of material only this material shown the OLPT type of, otherwise the rest of the material shown that some correlated barrier hopping model of follows the correlated barrier hopping model of the conduction mechanism. Now, if we calculate the AC conductivity with respect to temperature, then Arrhenius equation is there, and from Arrhenius equation we can calculate the activation energy for this material. As from the table here, if we plot the straight line fit for this higher temperature and low temperature, we can find the activation energy for the particular cases. Here I have noted down for the different frequency. As we see here that as the frequency get increases, the activation energy get decreases for all the case of material. material. This activation energy is assumed to have the contribution from the energy necessary for creating the charge carrier as well as movement in the free space. Now coming to the conclusion, first we have synthesized the material, that is sodium niobate modified bismuth ferrite, or we can say sodium niobate solid solution between the sodium niobate and bismuth ferrite, with some composition of x is equal to 20, 25, 30, 32, 38, and 340, and by the solid state synthesis method, and morphotropic phase boundary is find out at x is equal to 0.30. Below x is equal to 30, it is the rhomboidal structure, and after x is equal to 30, it is the cubic structure. Now, coming to the why this structural phase transition is there, the lattice strain and octahedral tilting is the basic for the, that is mainly responsible for the structural transition for this type of material. If we same images shows some phase near spherical type of grains, and as well as grain boundaries, grain size is about 2 to 3 microns are there, and Raman spectra will also shift due to strain produced or induced in this doping concentration, and FTR spectra on the vibrations related to the different functional group, and electric characterization that shows some non-divide type, as well as from the impedance spectra we can find that NTCR PTCR type of behavior that suggested by the decreasing nature of the grain resistance as well as rise in the temperature. From the frequency versus AC conductivity data we can show that conduction mechanism are for the correlated barrier type for the most of the sample, and for the x is equal to 32, that is on the OLPT type of conduction mechanism is there, and the value of the activation energy decreases with the frequency. Here few publications are related to this paper. That is the first paper came we have published related to this is the journal of material science and material electronics, and after that ferroelectric came, and before that we just when we study, that is some it is come advanced science later, and one of my composition that got published in the ceramic industry in 2018, and few more data and few more calculations are till now it is going on that particular series, and we will do and we will publish the another journal also. And coming to the acknowledgement, I have deeply acknowledged to my gratitude to my PhD supervisor, Dr. H.S. Tiwari. He is from the Guru Khasida Central University, or Vishwavidyalaya, you can say, and another Professor R.N.P. Chaudhary. The dielectric and electrical data take in his lab. He is from the Shiksha and Anusandhan University in Bhubaneswar, Odisha, and I have deeply uh, uh, showing my acknowledgement to the UGC, that University Grant Commission, for providing me the PhD research fellowship, as well as obviously I am much thankful to all of my co-authors of my paper. Lots of discussions and are there when I was in PhD, and thank you very much for your kind attention.
Thank you, Doctor, for your presentation. Is anyone having any queries?
Yeah, I'm like to have some question if anything is there.
Yes, Doctor. You can unmute yourself and ask your queries. I hope there are no queries, Doctor.
Yeah.
Thank you, Dr. Manojit, for your presentation. Let's move on to the next presentation. The next presentation is from Dr. Katleho Makatjane from Baset Sana Consultants, Lesotho. Hello, Doctor. Are you ready with your presentation?
Hello, yes, I'm ready with my presentation.
Yes, Doctor. Now I made you as a presenter. You can click on the screen button to share your screen.
share my screen. Okay, let me open the presentation. And then, is it okay now?
Yes, it is visible. Can you make it as a full screen?
Ma'am?
Yeah, it is okay. Okay. You can continue with the presentation now.
Wait. Let me do this first. I want to.
Or you can make it as a reading
Yes,
mode.
yes, I want to make it this way. Yes. Is it okay now?
Yes, doctor, it is perfect. You can now start your presentation.
Okay. Talking about the statistics of extremes with application to extreme production of glass containers. And then here is my presentation. Statistics of extremes. Let me do this. Statistics of extremes. It's all about.
Sorry, doctor, for the interruption. Can you please give brief introduction about yourself before starting your presentation?
Okay. My name is Katlaho Makachane from Astana Consultancy. I'm a business and risk analyst at Astana Consultants. So I just obtained my degree in PhD statistics in Northwest University in 2019. So currently I'm with Astana Consultants as a business and risk analyst. So now with the what am I doing now? With the statistics of extremes, it's all about the use of extreme value distributions. And in this case, I've just applied the extreme value distributions for the glass container production of glass containers. So now, when did the extreme value started? It started in early since its theoretical developments mostly in the century before 1920. That's when now the theoretical aspects of extreme value distributions started, and then its first major applications to real life problem pioneered by early 1940 with the person so called the Gamber. And then, although the theory and application of extreme values have been extremely advanced and it was utilized in countries, and then in terms of applications, little has been done in many developing countries in Africa, despite the abundance of areas and applications and the other types of data into other countries. And then in class production, the choice quality production frequency probability of extreme distributions for a particular production remains the subject of an ongoing research. So it is an ongoing research about the application of extreme value towards extreme production of glass containers. And then the work contained in this study is a contribution towards the the problem that addresses the developing and economically challenged countries in Africa. And then for methods, and then there are two types of extreme value approach, which is the block maxima and the peaks, block maxima or block minima, and then peaks over threshold, which are used in this study. Recent theoretical results by Ferrier in 2013 has showed that despite its deficiency due to data loss and results in a blocking using the block maxima or minima approach, is more efficient in the number of situations over the peaks over threshold. The two approaches are quite comparable for large sample sizes. A number of candidates distribution are investigated for their goodness of fit to daily maximum class production in realization of maxima in this study. And then for data analysis, the findings of this data reveal that the generalized extreme value distribution is the most appropriate distribution to apply in the extreme class production. And then the distribution can be recommended as a likelihood function for the regional and spatial extremes production frequency analysis. And then this can addresses the issue of cumulative effects on daily class production, and a comparative analysis of 6 annual moving sums was used. And then the findings also demonstrates that the 6 annual maximum time series are not significantly different from the characteristics considered in this study. And in an attempt to reduce uncertainties in estimates, a Bayesian Markov chain Monte Carlo approach with the conjugate prior and the generalized extreme value likelihood function is used to model the extreme class production. And then the findings of this approach reveals that the addition of prior information in bias MCMC substantially reduces uncertainties in the estimates and in the precision and in the predicted extreme productions. The largest order statistic models developed in this study are also promising, and the standard errors of the estimates of the parameters are substantially reduced. And then our conclusion is, among the major contributions of this study is proposed proceeding the determination of the 8 days windows period used in extracting independent R largest order values with the same year of the R largest order statistics approach. And then also we have found that this approach can be used in the demand and supply of the class production. Thank you.
Hello, Doctor. Thank you for your presentation. Is anyone having any queries? I hope there are no queries. Let's move on to the next presentation. The next presentation, hello, Dr. Ketleho. Thank you for your presentation.
Thank you.
Now let's move on to the next presentation. The next presentation is Dr. Barush Kumar Yadav from Tribhuvan University, Nepal. Hello, Dr. Barush. Are you ready with your presentation? I hope Dr. Barush has not arrived yet. We'll move on to the next presentation from Dr. Saubhagya Lakshmi Behera from Setruan University of Technology Management, India. Hello, Dr. Saubhagya Lakshmi. Are you ready with the presentation?
My presentation, no? No?
I hope Saubhagya Lakshmi also have not arrived. Hello, Dr. Khanadasan. Are you ready with the presentation?
Yes, I am ready to presentation.
Okay, Doctor, now I'm making you as a presenter. Kindly join, share your screen. And can you please give a brief introduction before starting your session?
Yes, ma'am. Okay. Screen is visible, ma'am?
Yes, your screen is visible. As Doctor, you can continue with the presentation now.
Yes, ma'am. Yes, yes. Screen is visible, ma'am?
Your screen is visible, but there is an issue with an audio. There is a lot of disturbance from your end.
Yes, ma'am. Okay.
Can you please resolve and start your presentation?
Okay. Good evening, one and social year. I am Dr. S. Kannadasan, working as an assistant professor in the Department of Electronics and Communication Engineering from China College of Engineering, Karur, Tamil Nadu. India, also India. Okay. Thank you for opportunity for interest webinar class on the ceramics to present the paper design development of composite master batch using ceramic substrate. This is my one of the research paper doing the research in the field of microbatch. Nowadays, a lot of microbatch design nowadays researchers, but I have chosen for a ceramic substrate. It is one of the frequently used ceramic substrate, but it is a frequently used for textile industries using the ceramic substrate for batch. My work is designed for a one shape of on shape and also combined with the pin diode. That pin diode is therefore operated in a variable antennas. That means of diode operation is nothing but a on and off conditions. Still, I have in each and every thickness in a variable in a human bodies in a variable devices. You use substrate the ceramic substrate. We can calculate the normal substrate of the normal substrate. So I can use it for the ceramic substrate. Then second. There's nowadays a wireless communication network is a nowadays in the derivative subject, but is a fabric antennas. It is type of antennas, not a hand grip antennas. That is a high shape antenna. In this antenna, again used for two dual mode frequencies. In these dual mode frequencies, we can actually with the capacity ranges also the reached 3.8 picofarad and 1.8 picofarad with the help of Zener diode. Then the operating frequencies in 2.5 GHz to 4.0 GHz. The antenna will be built in here. The structure is 80 mm to 60 mm. We can use it for FR4 and also the ceramic substrate. We can both the calculate the ceramic and FR4 will classify the substrates. Okay, in the switching dimensions, each and every switches we can dimension. I will mention the dimension 0.7 mm, 1.0 mm here. Relative perimeter of 3.6 and height of the substrate is 1.6 mm. The batch of the plant substrate is 50. Normally, the antenna can fear input impedance matching is a important parameters. So, I choose for input parameter is 50 ohms. Therefore, the impedance is a coaxial cable. That means a ground line is fixed to a coaxial cable. In this research work, my structure is a better gain for 8.2 decibel. That means of 86% for efficiency reached in wireless devices. That means of wearable devices. Therefore, the also high written the minimal high and the minimal resistance I calculated. The high losses is minus 3.9 39.0 decibel to 1.68 decibel nowadays. Also the VSWR, the voltage standing ratio, my structure is here, proposed structure is here 1.78 and 1.9, maximum 1.7 and 1.02. Normally variable devices, normally they are used for various devices, wireless personal network, wireless home area network, robust wireless network, they are upcoming the 50th generation. So it is a based on the variable devices. Sometimes it's included in here, surveillance also included in my devices, satellite communications and also the operation emergency rescue operations. Okay. Therefore the in future only multi-frequency antennas we can use it for decrease number of components, the effect of the hardware texture. Is one of the main advantage of this. Nowadays, switches concept is used for a batching antennas. In this batching are micro-mechanical electromechanical switches. That means MEMS is electronic device and devices. That means a single silicon substrate, you can microchip in a MEMS signal to fabricate in each and every diode. I can use 3 more diodes, and in 3 more diodes we can include in a micrometal switches. We can calculate the each and every diode operations in a return loss and also the calculative same also. Therefore, online use in RF matches also. This literature in this 2020 paper, you can design for in this ma'am Pandey ma'am Devi researchers can discuss about the Joule substrate. In this substrate, a 2019 paper, you can serve RF technologies in this minimal order characteristic systems. Then there most of the literature I had done. So the accept panana, nothing but a shape panana, is substrate accept panana, a cloth substrate. In my analysis substrate to calculate the accept design and also implemented in the wearable devices to radiation the ground plane is in the ground plane sectors. Then this is a manufacturer for wearable fabric and in garments also. Therefore, design accept and it is used for a electrotextile to cut easily. That means that the ultimate the diode operation is to D1, D2, and D3 for traditional diode operations. We can implement the resistivity of the each and every material to easily to cut and every pieces to cut easily the electrotextile textiles. So it is easy used for HSA brandana. And also normally the shape microchip batch we calculate the length and width of the structures. Length is also called basic general formulas. In this type of Zener diode, I have capacitor switches with the aid of switches also. The switches is the main concept for resistance of on-off condition of the each and every calculator of the VSW and also the ceramic substrates also. Therefore, the conductivity of the fabric also. This is my third element of this textile substrate and the every textile is substrate. This my structure. This is also we can calculate for W and LB. Some of the structures we can design for some of the rearings are used, and also the in the user for accept we inbuilt the two type of diode in Zener diode. That means of front and back ratios. We can calculate maximum normally basic formula microphone width of the C into 2f0 by 2s1r. Normal of F of a diode constant, calculate the effective length and also the length of dimensions. All close length of the length of L is equal to L efficient minus 2 del of L. The sum of the calculate of the 12.12 nothing but length and width of the batch of each and every batches. Each and every diode operation will calculate the length and width of the each and every operation. So impedance also calculated in also in this structure of the also. Normally F0 is the resonance frequency, W is width of the batch, L is length of the batch, adjusted thickness, and also for the epsilon is a relative current of the L substance is the speed of light. This my dimension of this my proposed work. L for length 16.79, W 27.75, then WA 10.89, WP 10.89, then WC 0.5, LP 8.39, LQ 8.39, and LQ1 0.5. This my algorithm designed for one more algorithm. First algorithm is test code. Test code is nothing but I get chosen for a diode operations. So I get decide for a test code operations of the each and every diode of the operation. So in the diode test code operations, number of iterations, how many iterations in diode in the test code operations. Okay, we can calculate the x0 to x of n is the number of diodes and d is the output. Therefore, calculate length, width, and the dimension of the. We can analyze of the diode for n greater than 2. Other that means of resonance frequency is greater than 2f. The analysis of diode. If diode D1, D2 greater than, the loop is also closes in the N also. The N also the existing the loop. After it goes to the else if Dn less than equal. They return to N, then also the end of the N. Therefore, normal, we can discover two parameters S and V. In S parameters, N for I loop and J loop, and also the N and I in the L length and the N and I and width. That means of length L and width. We can call it S parameter V parameters. In the base parameters, D1, D1 on, D2, the first parameters. First discuss S1 to 1. Second time, yes, D1 off, D2 on. Third parameters, D1 and D2 on, both of them on and off condition. We can calculate the kind of port the P and D. That is the conductivity of the vehicle and devices high and low. Therefore, high means S plus 1. That means of increment. In low means that means L plus V plus 1. Then the output at the end of the program. This means the production test of the diode operation of the algorithm. Then our fabric used for normally a cutoff is proven is excess. So usually using the biometric XR used in the textile substrate also. Therefore, in textile substrate also a little bit of the computer and information processing devices which allows the sensor of the each and every diode of the every devices we calculate the sensor about. Each sensor, you analyze the sensor about the thickness of the and also the where you have the substrates, and also easily to cut off the devices under using the reception. In a high resistance, you remove the on and switch off the Texas heat Texas all the diode of operation also switch off the conditions. Therefore, heat Texas component is small components and calculation. This is my the flow chart. Nothing but equation based calculations. Calculate length and width the updation. Okay. Already discuss about the algorithm also. N plus 1, n greater than analysis circuit. Diode operation D and D to the gain operation. Last of it P for threshold and another T for threshold. We can calculate the on application based on the threshold calculator. This is here. Proposed is here. Proposed production step used a lifespan. That means here nothing but every textile now every textile also even textile student is also the we can easily to cut the ceramics ceramics flexible fabric annas. So easily the flexible annas in the textile voltage to provide the production textile using the polyethylene cloth. In easily electric conductive polyethylene textile technology used to apply the ground plane in a substrate. So also the second is a constant thickness and the constant perimeter cloth. It is the most important of the second set of cloth substrate also. This is cloth are picked also. There is a sum of the calculated Frisch transmission formula. In Frisch transmission formula, nothing but here PT GT GRF into lambda square divided by 4 by h square. Power function of the each and power how to the normal transmission in sum of the power is the distance also. We can PT is equal to nothing but PT GT GR and lambda square 4 by R into square. That's the equation number 15. Therefore, PR is nothing but here power at the receiving antenna. That means here on a how much the power is received from the PR and the PT output power transmission output power transmit to the diodes of the so PT. Then GT gain of the transmit antenna in and GR is gain of the receiving antenna. Then lambda is the wavelength of the then frequency of the antennas. The R is the distance between antennas. Distance with nothing but here two more diodes used for back and front and below. Each and diode 1, diode 2 and also on diode 3. Compare with it also the diode distance between alpha distance called for R. Then the result discussion normally I already discuss about the impedance 50 ohms because it is a lower and higher frequency of the grounded structures also. In general, higher pair and lower function also. To stop the teasing, there suppose a high current we doesn't to stop the teasing circuit to so use the fixed capacitor. It's nothing but a 3.85 recover and 1.85 on the structure of the in a DC voltage. So 1.8 first 3.85 is a fixed capacitor unless the 1.5 is unless the diode D1 D2. Another is same similar that in 3.18.5 is a pickup is a fixed capacitor. 3.8 is a variable capacitor connected the devices of D1, D2, D3 calculate the parameters also. This is DC to DC coupling capacitor. Then W in our basic normally basic assumption is important concept of the general diode in the human body. This is here normal not that means of here radiation is not affecting a human body. It's a more basic effects of spacing and measure window. So in the general diode we can use it for diode operations on of condition. Human body from radio wave to shield the radio wave to shield. That means to general diode to shield the human body from the human radiation. So this is a variable devices. Normally I can use for and also ceramic substrate 3.6 pyramid and the cancer 0.055. This is a structure and also 1.6 thickness of the This is a ground plane of structure. This is my antenna for accept antenna. This is my ceramic substrate and also the and this is a fabrics also. This is a non-conductive element for polyethylene coating. This is all in water absorption. Polyethylene coating is a salt antenna from water absorption and the corrosion is used to protect the substrates. Okay. The reflection coefficient under radiation quantity. The radiation is nothing but a graph radiation part in the space coordinate. Radiation efficiency is nothing but power radiated from the maximum divided by the power radiated input element. That means the power radiated divided by power received. P radiation power radiated by the antenna, power absorbed by the antenna. This is there is nothing but T is equal to U divided by UI. That means radiation intensity of the given direction from the antenna and also radiation in the overall direction. That means of the direction of the antenna. You radius of the antenna. How much radiation of the antenna from the receptor and also how much radiation isotropic antenna that is dPi. That means of dP divided by dPi. That means the power of the total power of antenna. That means normally the power gain is calculated in decibels in the power of decibel. So return is calculated as the RL equal to P is equal to return loss RL is equal to 10 log PR by PI. PR is nothing but a power supply and also power reflector. PR means power reflector, PI is a power supply. Then VSWR is nothing but a transmission line. That means a superposition waves. That means how to transmit the waves electric parameters, current, voltage, and field power into VSWR. So VSWR is equal to V maximum and V minimum. Okay. Therefore, normally VSWR is gain obtained between 1 and 2. Is a VSWR is a maximum 2. This is the best one. Then this is my reflection coefficient D1 and D2 of. In D1 on conditions, we can use it for green color. In 3.21 is minus 15 point decibels. So normally increases in the green region also decreases from the linear. It also goes to the each and every step of the diode operation in D1. And also the same similar to D2. D2 of condition, here name VSWR range, return loss. Then another 3 conditions also applied. D1 and D2 on D1, D2 of D1. D1 and D2 is a green color, and also D1 and D2 is the analysis of the light colors, and also the violet colors is D1, D2 on. Then VSWR, that means 1 and 2. A maximum range is 2. Maximum range is 2. My range is 1. Maximum range is to reach the 2. Okay, we can D1, D2 of here color of now, and the D2 is on. Therefore, similar that T1, D2, D3. These 3 are similar conditions. Then normally the Z1 varied. Other diode of operation Z1 and Z2. In Z1, 2.85 adjusting capacity ranges. Stable 1.85. Similar that in Z2 vary from 3.8 to 0.5. Adjust fixed in 1.88. We can efficiency 38%. We can efficiency 60%. In the reverse bias, this is a part of the forward biases. In reverse bias conditions, the open circuit high frequency band is utilized. So constant frequency ranges from switches, the VSO can reach 1.2, 1.8 VSO in on-off conditions. So therefore, normally in an on-off condition, use of radiation pattern. Radiation multimedia, each and every electromagnetic, electric field and electric field. Magnetic field is the distance for radiation pattern. How much analyze the electric field reached and how much analyze for each of electromagnetic field reached in here, radiation of the maximum substance. In D1 option. In normally, the diode are connected 2 volt DC supply, 2 volt DC voltage applied from the small potential copper wire. But the calculation of the inside Texas substrate also. In normally, the height of the source decrease in ground plane 100 to 80 mm to 45 to 45 mm to increase the bandwidth also. So, accept of the batch also. This is my performance of the radiation another. Normally, this is the size of the each and every nanostructure. Usually, the frequencies also. The radiation is omnidirectional broadside. We can also similar at D1, D2 on off. Both look similar at same of the calculate the every size and frequency calculate for on and off conditions also. This is my radiation patterns of the Hasselborn electric field and also magnetic field. Then the overall of the efficiency, my research work VSW representation and gain and efficiency of the radiation for frequency 2.5 to 9.5 analysis. Each and every on and off size is also calculated. The gain is also calculated. Then efficiency is also calculated. Reflection is also calculated. Then VSW is also calculated. Maximum reach is 4.2. Maximum reach is 8.2. Gain is 8.2. Minimum 4. Minimum for 3.8. Therefore, for maximum 3 minus 38.08. Minimum is also the minus 14.56 reached. I mean maximum is VSW is 1.7, 1.8. Sorry, nor minimum is 1.2 reached. This is my performance analysis of the gain of the parameters. Normal instead of 2.5 frequencies, 4.2, 6.8, 8.2, 6.5, 6. Some of the delay from diode operations also delay. Then of the return losses also. The returns are calculated for decibel in here. Minus VSW is calculated also. The efficiency also perform analysis. Nowadays, conclusion is my law. We can use for textile materials, electron nylon, steel cloth also. They have low surface resistance also. The inside the carbon, other items also. This iron is lightweight, strong, and possibly easily caught by conventional iron. In this system, normally 2.5 GHz, and normally a lot of the structure VSW, all of the parameters also discussed. Log 8.32 from 2.25 GHz. Also dual transversals are analyzed. In Texas now you got tools of the lower end. I get choose for capacitor 2 more capacitors also. So I get over 2 tools for 2 higher lower and higher frequency bands. This is my references also. I have already published the papers. Textile Research Journal. It means a sage publisher. In another journal of Textile Institute, Taylor Francis publisher. In another, this is a one and two is a essay journal. Number 3 one is a Journal of Green Engineering. This is Scopus journal. 1 second. This is my publication paper, genotype papers in Texas, in TF Taylor Francis also. Another one is Sage journal also. The impact factor is a 3.2. It's a high impact journals impact factor. This is a textile research journals for a assay panama. Thank you for a nice. Thank you for contributing. Thank you so much. Any queries? Thank you, ma'am. Thank you for option for class and seminars, webinar and industry class and ceremonies. Thank you so much, ma'am. Thank you, all present here. Thank you.
Thank you for your presentation. Is anyone having any queries?
No queries. Thank you so much.
Thank you. I hope there are no queries. Now let's move on to the next presentation. Thank you, Dr. Kanadhan San. Now we move to the next presentation. Hello, may I know the user 134276349? Can you please unmute yourself and can you please say your name, please? Okay, I hope there is no response. Now we'll move on to the next presentation. The next presentation is from Dr. Shagir Gul from Government Postgraduate College, Mansehra, Pakistan. Hello, doctor. Are you ready with the presentation?
Yes, ma'am, I'm ready here. Can you please play on the presentation from your side?
Okay, I have made you as a presenter. Okay, I will be playing from my side too.
Okay, thank you. Can you share the screen?
Yeah, the program manager Catherine will make.
Yes, the screen is visible.
Now it is a full screen. You can start with your presentation now.
Okay, thank you very much. Hello and assalamu alaikum. Namaste to all colleagues here listening and attending international webinar on ceramics and composite material. Here I am Dr. Saghir, Assistant Professor of Chemistry, Government Postgraduate College, Mansehra, Pakistan. My research topic is on polymer composites, and from that topic I have just put out for today a review article which I have to discuss. The review article addresses the research progress in preparation and properties of nanocellulose reinforced polymer composite. It is a part of the project which is under process in Department of Chemistry, Government Postgraduate College, Mansehra, Pakistan. Next, please. Next slide, please. Can you click on the next, please? Hello.
Hello, doctor. May I know which slide you need?
Yeah, can you move on to the next slide, please?
May I know the slide number?
Slide number 2.
Yeah, we have also already opened.
Okay, here, it's okay, it's fine. This slide addresses the abstract of the review article. This review encompasses the progress and challenges related to the preparation and properties of different kind of polymeric composites, which are usually reinforced with the nanocellulose. In this review article, the various processing conditions for fabrication of these type of biocomposites have been addressed in detail. Cellulosic material are used by human beings for the past thousands of years, including paper and textile industries, because of their beautiful properties like sustainability, enriched surface chemistry, and low cost. Similarly, the nanocellulose, which is obtained and synthesized from the natural cellulose, is used for the fabrication of very elastic, reliable, and beautiful type of composites, which have very good mechanical properties, thermal properties, and which can be utilized in many industries. Can you please go to the next slide? The introduction. I cannot see the next slide. Hello.
Hello, doctor. May I know which slide you need?
Introduction. Slide
Yeah,
number 3.
it is in the introduction. Are you able to view the screen?
No, actually I am just viewing an abstract slide, so that is the reason I'm so introduction.
We are in
I
introduction
will
slide
address here.
only.
Okay, I can view for the abstract slide from here. Okay, now it is bioeconomy. Can you go back to the introduction slide?
We are in the introduction slide now.
Okay, I will go on. I will go on because there is some issue of the internet, so that
Maybe
we
the
are
issue.
not in line with each other.
Yeah, we are in introduction slide. That's why we are confusing
Oh,
about
okay,
that.
here,
Now we are in
yeah,
introduction slide.
here it is introduction. Yeah, it is introduction slide now. So the introduction part, the pictorial summary shows that how this cellulose is helping humanity. On the left, you can see that the plant material, which is usually used as a source for obtaining cellulose, and it can help us, humanity, in various sectors, starting from automobiles, the clothings and paints and varnishes, and every field is covered from this cellulose material, and which is the reason for a bioeconomy. Renewable materials can be obtained from it, which can be used in food, chemicals, and obtaining bioenergy. Less waste is generated with low carbon footprints. Next slide, please. Next slide addresses another pictorial summary of the use of cellulose material in the bioeconomy. So it is used for the cutting purposes. It is obtained from the wood and it is used in the clothes. We can also make liquefied biomass from it, which is used as a biodiesel also. It is also used as an adhesive, for example, in plywood type of applications, and it can be converted to very rigid pure form, and that can be used for many materials, and mostly it is used for production of energy also. Next slide, please. Now this slide addresses the literature record which shows that why nanocellulose is so important to the researchers when they are dealing with it for synthesis of various type of composite and various type of products. So the most abundant natural polymer is uh, cellulose, which is biodegradable. It has low density, it has high aspect ratio, high surface area. It can be used as a filler to produce nanocomposite, and these nanocomposites usually have extensive mechanical properties, and they are responsible for production of green composites, and sustainable environment is ensured by using of nanocellulose as a filler. They have application in food and pharmaceutical industries. The literature record also revealed that a wide variety of surface modification of cellulose and nanocellulose have been used in various type of polymers as a filler, and it has endless application in many industries. Next slide, please. This slide shows a small pictorial summary of the structure and fabrication of the cellulose. On right, we can see that it is a biopolymer. The glucose molecule, or we can say the monosaccharide molecules, are linked together to form this polymer. The hexagonal structure is very much clear, and it is obtained from the plant material. And the most interesting thing about the cellulose is that it has two very important regions. It has an amorphous region also, and it is composed of crystalline region. And in the SEM image, that is scanning electron micrograph, we can clearly see the nanofibrils obtained, which are present in the cellulose. Next slide, please. A variety of methods have been used for NCC, that is nanocellulose isolation, as per literature record. On the left of the screen, you can see that these are the sources from which we are obtaining cellulose. Either we can obtain this cellulose from the cotton, either it can be obtained from the cell wall of the wood, or it is obtained from the trees. Then it is subjected to milling and cutting, and then followed by depolymerization with glycols to break the bonds, and then it is centrifuged and rinsed with solvents or water, whatever is applicable, to get either nanocellulose suspension in organic solvent. Either by bleaching with water, we can get suspension of nanocellulose in water, and or by drying, we can also get the nanocellulose as a dry powder. So this whole process is repeated 3 to 5 times in very sophisticated type of machinery or instruments, which are shown in my next slide. uh, After this slide, that is, this show the powdered form of the nanocellulose which have been dried and obtained. And on the left, we can see the micrographs for the nanofibrils of cellulose, which clearly depict that the nano size of this cellulose. And it can also be obtained as a suspension. In one watch glass, we have the suspension of this nanocellulose. It can be also in form of paste. So this is the whole thing, that the nanocellulose can be obtained from very cheap sources, trees and other plant material like cotton, and we can obtain it, we can grind it, we can dry it, and we can save it for our future studies. Next, please. So this slide, next please, next from this, which shows the instrumental setup. This slide shows the machinery, the sophisticated machinery which is involved for the production of nanocellulose from the raw material like wood, trees, and other plant material. This type of setup is available in the labs, sophisticated labs, and also it may be equipped with some industries. So we start with the raw material, and we can obtain the nanocellulose in any form, whether we can produce it in a dry powder form and either in form of suspension. Then it is subjected to the morphological analysis and XRD analysis to check whether the size of the fibril is in the nano range or not. Then it is incorporated in various type of polymers as dispersed phase, and these polymers interact with the cellulose in a very good fashion because both have similar nature. The cellulose is hydrophobic, and similarly the polymer is hydrophobic, and both have good compatibility. At the end we get very beautiful properties, mechanical properties, and other related properties which we will address in our application part for the composite materials. Next slide please. This slide shows the life cycle assessment of nanocellulose in different research articles which are present as per literature record. That is the cellulose, nanocellulose obtained from cotton fibers, nanocellulose obtained from coconut fibers, either by acid hydrolysis or by depolymerization and other techniques. So these are various parameters which shows the life cycle assessment of this nanocellulose in different units. Next slide please. So this is a pictorial summary of what is the market price of nanocellulose obtained from the raw material. So various companies shows various degree of purity and various size range of the nanocellulose. So they have different market prices ranging from $100 to $1,000 per kg. Normally, on average, when you compare all the industries, the nanocellulose which is sold in the market is under or up to €50 per kg. Next slide, please. This slide reveals the literature record of all the publication and patents up till 2018, which have been published in international and impact journals. You can see that the record shows more than 500 publication and patents per annum for nanocellulose production and nanocellulose type of research, in which it is either used as a filler or it is used for making composites. Connection lost, I think. Okay, sorry for a little interruption in the connection. Can we move to the next slide please? So after the literature record, we can assess the importance of nanocellulose for the synthesis of various kind of materials. This is a list of applications in the next slide. Can you go to the next slide? Applications, under the heading of applications. There are various industries on the left side, the paper chemical industries, the coating industries, the packaging and polymers, pharmacy, construction material, cosmetics, and electronics. And various application in these industries are in paper coating, for example, for clear printability. They are used in coatings. They have good mechanical properties. Nanocellulose shows good mechanical property, good viscosity modifications. And in food packaging, it shows better barrier properties for various type of gases and various type of solvents, and all kind of polymer composites which are synthesized based on nanocellulose, on which our project is running at the moment. they show better mechanical properties. We are interested to improve the mechanical properties of low density polyethylene and other polymers like polypropylene, etc. They are also used as drug carriers, for example, in tissue scaffoldings and drug delivery. And they are also used in the concrete for construction material for when there is high flexure strength of 30% is required. Can you move on the next slide, please? This slide addresses the commercialization of the nanocellulose for the synthesis of various kind of material. The main and most frequent question asked as per literature record are that what is the price of this very culprit? How much can you produce per day? What is the benefit of using it? Is it toxic? Could you provide some formulation how to use it in our products? May I have the MSDS document for your product? Is the sample free of charge? How much sulfate groups can be there on the surface? So these are the common questions which are usually addressed and answered as per literature record. The conclusion, what we draw conclusion as per this literature review, that nanocellulose is the subject of intensive studies and application worldwide since it is a bio-based and biodegradable type of species. I think you will move to the next slide for conclusion. Yes, here. Please. The number of publication is rising exponentially as well as the number of patents. As I have shown one of the pictorial summary, different lignocellulosic sources can be used. Low acid concentration, favorable mechanical and morphological analysis and morphological properties can be achieved by using nanocellulose as a filler. Nanocellulose is prepared as a suspension in organic solvent or in water. So both type of medium can be used for production of nanocellulose. Pilot plant offer 65 kg per day of nanocrystalline cellulose, and water suspension 6 to 7 kg per dry weight nanocellulose can be obtained. And the incorporation of these nanocellulose in variety of polymers can yield to the composites with high mechanical properties, best flexure strength, elasticity, and high thermal and other important properties which are the demand of modern day industry. So this is all about today's presentation. Question and answer. If anyone some have queries, he may ask question regarding this review article.
Thank you, Doctor, for your presentation. Is anyone having any queries? I hope there are no queries. Thank you, Dr. Shagir, for your presentation.
Thank you, ma'am. Thank you to the organizers of the teams. Thank you.
As we have moved ahead with the sessions, and unfortunately few speakers are not turned up to today's webinar. So by this, we have come to an end of day 2 webinar. I would like to thank all the attendees and participants of today's webinar. Hope you enjoyed the webinar and gain knowledge from the sessions. And we'll be glad if you could join us in the next webinar if it is scheduled, and the dates will be informed to you by mail. We will be very happy if you could share your opinion and feedback with us via mail. Thank you.
Thank you, Clara.
Thank you, Dr. Shagir.
Will you share the certificates regarding the webinar on our email?
The respective program manager will be sharing you via mail by the end of the day.
Okay. Okay. Thank you so much. Thank you for all the organizer. Good luck for the future.
Thank you, Dr. Shagir. Have a nice day.
Have a nice day. Thank you.